Good morning. And this is the lesson that we did in lab. So the do now is how or why does the motion of an object change? And do you know why? So look at these pictures and try and tell me how or when does the motion of the object, the movement, change and why? Now our do now is we will investigate and describe Newton's first and third laws of motion. We can use the word inertia. We can give and identify examples of inertia, describe those first and third laws, complete an investigation, and describe force pairs. So as we're looking at this, first of all, here on the left is Fred and Barney. So the car is moving at a constant speed. So the forces acting on the car are the same, and they're equal and opposite as well. So they're the same. However, here on the right, there are these two cartoon cars right here, and the forces acting on these both cars are different or unbalanced, so the motion of the car will be different or unbalanced, because what happens to this bigger car will be very definitely different than what happened to this green car. So I'm gonna post a sheet in over the next couple of hours in your it'll be posted in the assignments, and it will say absent, and it will say Newton's first and third laws. So you can have this for your notes. So really, Newton's law pretty much has two parts. One is about an object never moving because there's no outside force. So it's just sitting there. Nothing's happened. But then we also have another one where there's no forces moving on this object. This object here is in motion, and it will never, ever stop. So that leads us to Newton's first law. Object in motion will stay in motion at the same speed and in the same direction unless an unbalanced or opposite force changes the movement or the direction of that object. And objects at rest will stay at rest unless a force makes them move. So the more mass we have, the more inertia, the less mass, the less inertia. So the investigation today, that are the other four questions, is the NFL video, and we're going to look at that in a minute. Go Puck Go, where you can use those air hockey pucks, the flying teddy bear fiasco, and the balancing penny cup. So right here is a great video of inertia in action, and you can answer question 1 from that form if you wanted to. That would really help you, and they really kind of help clarify what is mass, what is weight. Mass is how much we actually are, and weight is how gravity affects us, and they're really great about it, and the effects are amazing. So here at Station 2, we worked with a hover puck. We pushed it when it turned off, and then we pushed it when it was turned on, and we made an observation. If you guys remember these from class. We also have a how force is measured. We didn't ask you to write about this, but this is that spring scale or that Newton scale that kind of really gives you the actual mass of an object, and the spring compensates for gravity. All right. Then we had the flying teddy bear fiasco, where you push a scooter with both before having the teddy bear strapped in and afterward. So there are lots of really cool stuff here to look at. You can kind of Google some of these, like how seat belts work. And lastly was balancing the penny. And as you see here, you could put balancing like a penny cup in science, and you could Google that and probably find some really cool videos on YouTube. Now we're going to go to the second sheet, which is Newton's third law. For every action, there is an equal and opposite reaction. So like if on this, when you push off on the diving board, it springs down. When you swing, we go forward and backwards. So there's always an equal reaction. So the greater the mass, the greater the acceleration. The smaller the mass, the smaller the acceleration, because there's not as much there to move. So just some examples of that right here. And on the form it says the soccer ball accelerated to the left because it has less mass than the arrow. So equal mass, the same acceleration. So right here we're going to watch another video about Newton's laws, third law. We're going to talk about bumper cars, roll with it, and Newton's toys. Similar idea, just you can Google some of these like bumper cars in physics. This is actually, number 3 is a Newton's cradle. So we'll take a look at those. So here's the video. You want to watch this and answer the first question on the second sheet. And then on the bumper pucks, these are those little ones, you're going to gently push the two pucks at each other, turn one on, turn one off. Remember how it happened. And this would be action reaction. You can always Google these. Roll with it talks about where you put this marble. This is a flat Newton's cradle. So you have the 4 here, this 1 here, and you can push it and you'll see what happens. That one, if you can do at home, that's always great. And lastly, we have these little clackers, and you've seen those spring-loaded toys where you put them on the desk and push down and they fire off. And you can, again, Google those Newton's toys and see what you come up with. There's a really cool video here about Newton's laws and skates and how it uses all 3. And so my question is, you are sitting in a moving car and the driver suddenly pushes down on the brake. Describe your motion if you are not wearing a seatbelt, and how does this relate to the first law? So here we go. We will see you guys tomorrow. Have a great day.